computer. Okay. Screen share. All right, let's do this. So here is what we were doing with last time around. We had something called, by the way, if you can't hear me properly, just please let me know. We had a series of class. Well, we have one class that we had created, which is called human.h. It had a constructor. It had a destructor. We could even look at multiple constructors if you wanted to look at that. We had getter methods or accessor methods like get name, get mother, and get father. We had set name. We had two different versions of set name. In fact, we will look at this very soon when we look at inheritance, if you haven't already looked at those videos. Inheritance lets you have essentially thus, not inheritance, polymorphism. This is function overloading, as in I have the same function, different inputs. It will call the correct function based on the inputs. You don't need to tell it which one. It figures it out for you. As long as there's a matching parameter, it will figure out the best matching parameter. That is fairly common for most languages. So we have we have a set mother method, a set father method. That's great. So these are our mutator methods. Should call them functions each time. And so these will actually set our values inside of whatever we're storing. So we have a human object, an instance of the class human, just like I am an instance of class human. Humans describe all of us, but I am a particular instance of class human. I am an object of, I'm a human object, if you will. I have my own data. You have your own data. Things that belong to you, not anyone else, you. Same with a tree node. It has its own data. That one node has the data associated with that node. My cat has attributes associated with that particular cat. Okay, there you go. Thanks, Jacob. So besides all of this, though, what I want to do, what we're going to be looking at, and I would love to get your feedback on where you're getting confused. We're going to look at another class. We're going to wrap up a bunch of these humans in a particular class. We won't be doing this. Well, we could try. Can we do that? Let me see here. Can I print out the entire family tree for a given person? I think I should be able to do that. It's going to look weird. Just right up off the top, I'm going to say it's going to look weird. That's the bonus question that we're going to be looking at for the assignment as well. But in the meantime, I'm going to do something different. It's not going to look like the tree. The tree, all it's going to have is the root of the tree. All I need is that one thing at the root of the tree, like your C colon folder on your desktop for your computer, what your hard drive is. But you know what? We're not going to necessarily do that, which the tree 2400 class, all it's going to do is have a bunch of methods, and all it's going to do is keep going to the root and say like, hey, by the way, print yourself out. Or it might traverse the entire tree, but it's just going to have functions that then call things involving the node, the root of my tree. I'm going to do something a little bit different. I'm going to actually, so we have this this class, human. We have a human.h, which all it does is it says what data I have, and it says the prototypes for all the various functions I'm going to be dealing with. We have human.cpp. That's the definitions. That is the declarations. I'm just blanking on the word. This is where we actually define the functions, the function definitions. That's probably the word I was looking for. The function definitions, not just the declarations. It's how it's implemented. So if I go to human.cpp, we get this kind of thing. We say in the human class, which is, by the way, human.h, I'm going to now define get text info. Get text info is over in here. Let's say it's right, get text info right here, right? It takes in nothing, it spits out a string. Takes in nothing, spits out a string. That's all it's doing. I'm going to do one more of these, so let me just plop this in for later. It's only for the bonus question. And I'm going to, what could I do here for this? What I really want is to figure out what each part is and then expand out. Let's see what I can do here. Get let's call it get family history text. All this is going to do is it's going to get my information, the information about me and my parents, both my parents, and each of their parents, your grandparents, your great grandparents, great grandparents, whatever the case is. Okay, so I'm going to write a function eventually. And oh, I already made that name here. And all this thing is going to do right now, I'm just going to return this. Let's call it a to do. Define the function. All right. I just want to put some kind of little placeholder here. And I'm going to say string output representing all right. So it's just going to be David, Geraldine, and Bill, then Fred, Mary, Helen or Ellen, we don't know. We don't even have my grandmother's birth certificate because she was born in Outport, Newfoundland. Nelson, and I have no idea beyond that. I know a couple other generations for my Sprague side of the family, but nothing else. Okay, so it would just be, here's this person who knows this person, who knows this person, who knows this person along the way. And I'm going to also, I'm going to leave it at that. We're going to see how that works in a second. I also made a slight little change here because I want to check things that are bigger than this Cain and Abel example we had, right? I Cain, Abel, Adam, Eve, and oh yeah, I'm screwed, right? Because what great grandchildren are you going to have, right? You can't really, at least unless you do some really icky things in here. I don't know how this whole Adam and Eve story works out. Right? Cain kills Abel, and how are humans around? I'm all very fuzzy on this. Maybe somebody else understands this. Let's just see if I have any. No, nothing on the chat. Okay. If you have any questions as we come along, please ask away. So what I'm going to do is I'm going to make a class that takes in humans of some format. So I pass in these human objects one at a time. I'm just passing them in. Maybe they're pointers to these human objects. Doesn't really matter to me. And so let's make them pointers. And what I'm going to do is it's just going to be, let's say, a study group. So, or a set, human set, if you will. So I can't put the same person in the study group. And I also, I don't want to be able to put the same person in the study group. And I also want to make sure that, unlike a normal array, if I run out of space, I'm still going, I can just keep on adding people. Now, you could say, hey, let's use a vector class. And I'd say, that's a great idea. We're not doing that. Let's use linked list. That would actually be a wonderful idea. That would work just fine. I'm going to do something a little different. I'm going to make an array, and then I'm going to dynamically change the size of my array just because I want to show you some fun stuff. But you could have done it with a linked list. You could have done it with a vector. You could have done it with this. You could have done it with that. All I'm doing is getting a collection of pointers to humans. Yeah, that's it. We're assuming that we're not making a human. Actually, we could make a human. No, I don't want to make the human. So I'm just going to pass in one of these humans, and that will be members of this set. So it's for all intents and purposes, it's going to be an array of pointers to humans. That's it. Nothing else. So an array of pointers to humans. But what if I run out of space? So this is me playing around with something. We can do something, another problem if you want. I'm wondering if I want to do the bonus question for you guys first and talk about that first, but let's just make this class. So let's make a brand new class. I'm going to move this thing down to the bottom so that I can actually see what I'm doing. I'm going to make a brand new class, add class, and then we could call it study group. We could call it set, a human set, whatever you want to call it. So let's call it study group. So what we're expecting is that you cannot have the same person twice in the same study group. And if we want to add more and more people to the study group, we just add more and more people. There's no real upper limit. Now, the ugly way we were doing it before was we make this ridiculously sized array and say, well, I hope you don't run out of space. But we're not going to do that. Collection / set of humans pointers to consider a study group. There should be no duplicate people. All right. So it doesn't have anything to do with inheritance. It doesn't, or the parental relationships that we had before. These are just, you pass in a bunch of humans, your mom, your dad, and you can be in a study group together, or 3 random people can be in a study group together. It has nothing to do with the parent relationship. That's sort of what I'm trying to get across here. So let's do this. I'm going to, all right, we're going to use an array to store the humans. Okay. And I'm going to, I could make some kind of, make some constant int base study group base S group a size, a base study group array size, just because I don't want to write it out a whole bunch of times. Okay, and let's make that equal to, I'm going to make it very, very simple, hopefully, 4. Very small. I'm going to also, so that's going to be in my publics. On my private variables, I'm going to make sure I have this set of human pointers, an array of pointers. That's what the AP, I just like little things to remind myself because I'm not going to remember. An array of pointers to humans. Group, S group, study group. It should be S group, not G group. S group. Typing, very, very useful skill that I do not seem to have. Okay. This is just a point. We didn't even make our array yet. When I call my constructor, then I will make my array. Why? Because I don't know how big this thing is going to necessarily be at first. Okay, and then I'm also going to have an unsigned int S group size, let's say. I can also set that to something at the beginning. I'm going to have some kind of constructor. So study group, and I'm just going to start it up. I'm going to have some kind of destructor, study group. All right. And then what I might want to do is no one should know that I'm using an array. I could be using a linked list. I could be using vector. I should be able to use whatever I want as long as this interface still holds. No one should know how it's actually implemented. That's the point. So I'm going to throw in, I'm just going to be adding humans. I'm going to pass in a pointer to a human. I'm going to stuff it in this array. But so we're going to have some function called void add member, and it's a human. New member. All right, I'm going to add a member. I might want to have some kind of method that outputs all the members. So void print members, and I'm going to have that. That's all I need. And what other things do I need? Do I want to remove a member? Sure. So void remove member, and I'm going to give it the human that I'm trying to remove. To remove, And let's say I have an group size, something like that. That's it. Okay, I'm going to need this human class. I'm going to put that up at the top or right below here. So include. And I got this as a great question. Well, a student was hitting problems. I was wondering what was wrong with the code. And when do you use the quotes and when do you use the angle brackets? Well, the angle brackets, angle parentheses, are normally for, it says, look in your normal library where you store all your stuff. That's what that actually means. Meaning it gets you normally things like string.h. It gets you IO, standard IO. It gets you all of these pre-built things that all C++, like that a lot of C++ programs will have. Time.h. If I put quotes around it, it says, look in my local directory, essentially where I am right now. It'll look for human.h. It'll look for StudyGroup.h. That's about it, right? There's no other .h files. It's not going to find anything else other than human.h and StudyGroup.h. So I'm going to include human.h. I'm going to make sure I keep all of this stuff around. So let's have a quick peek at how this is going to work. It depends on how you want to. I like cutting and pasting because I'm lazy, so lazy. Human.h, StudyGroup, there we go. So I'm going to include StudyGroup. I have my constructors and my destructors. StudyGroup is going to be around everywhere. So I'm going to have things like, and lazy, and I'm just going to be copying and pasting right in front of here, saying, by the way, I'm going to define this stuff. Okay, first order of business, I have a constructor. I would like to use that. Then I'm going to worry about how I clean this thing up. What do I need to delete when I delete something? Each of these things are not going to really do much right now, at least. And this thing, I'm just going to return 0 here. Just, I want something to make it compile again. That's all I care about right now. It's not going to, by the way, but at least I don't think it should. It should yell at me. Is it yelling at me? I can't see the thing is in the way. But I'm going to assume that it didn't all go smoothly. But even then, even if it did go all smoothly, it's still not good. Okay. My constructor, it means how do I set everything up, right? I don't just blindly make these objects and it's perfect. Normally there's a setup. Like if I'm preparing a dinner, I have to set it up. I got to take it down, right? If I'm making Thanksgiving dinner, I got to do a whole lot of work to set up the table and set everything up. Then you eat dinner and then you do a whole lot of stuff to clean up afterwards. That's what the constructor and destructor are. Setting up the table, taking down the table, taking down everything, washing the dishes. They are different things, but they're both necessary for the main part, which is eating and getting, a bit overweight. Okay, so I have these member variables. Let's have a look at what those variables are. Here we go. So make a dynamic array of human pointers. Okay. So I have this member variable and it's going to be equal to new. I'm going to make a new array of type human pointers to human. And I need that constant here. So this is going to be my base starting size. This is how big my array is going to be. I'm going to make a new, hopefully this should work. This should be an array of pointers to humans. We're going to find out if I'm wrong. The group size is equal to 0. This, notice I'm doing something different. This is the size of my array. This is how many elements I actually have in my array. Every time I add a new member, this number, provided it worked, this number should go up. So I add a member, this number goes up. I add another member, this number goes to 2. When I'm done with all of this, I'm going to clean this thing up. So I'm going to delete an APS group. I'm going to delete this array. And I like setting it to null when I'm done. And then I S group size is equal to 0, just bookkeeping. When I'm done, I want to make sure everything is set to safe values, right? I don't leave things around. It's clean up after yourself, right? You don't leave the dishes on the Thanksgiving table afterwards, after you're done. You clean up. Otherwise, the next morning, you got, ants. So this is what a destructor is for. It is to clean crap up. I needed to do this. I do this to make sure that I don't accidentally use this. And I'm being extra paranoid, and I say, no. I also don't have any size. There's no group members now. Okay. So let's add a member. What does adding a member do? Well, first of all, I could do, let's do this. Is there any chance of me not having this thing? I could always do this. Assert APS group is not equal to null. I could just leave it as APS group. That's, if it's null, it blows up because it's false. If it's not null, then it's true. So this is the same as just saying APS S group by itself. Because if it was null, then the assert statement's false. If it's not null, as in there is an array associated with it, then the assert statement is true. Okay, I'm going to also need to include assert. Angled parentheses for assert. It's a library that is not mine. Okay, I just want to make sure in case of fire, blow up. If this array does not exist, ooh, something happened. Okay, I could have also just gotten out. I could have just said return. Okay, I is equal to 0. I is less than the number of my members that I have. Okay, once I know how to member, I go through each member. I check to see if P new member, I could do one of two things. Let me show you one of the approaches. Is equal to APS group. All right. Otherwise, so this is just notice what's something weird about this. This is a pointer. This is a pointer. I can have two objects with the exact same name, exact same credentials, exact same everything, be different objects, and this will happily just take the other person in. So you could have yourself, you could have your exact same self with a fake mustache on, and you're still allowed in the group. So the same person could be in the group twice if you had duplicates of the same object in this way. The other approach would be check the name. If the names are the same, don't let them in the group. But that's assuming no one has the same name. There are multiple David Spraggs. It's hard to believe, but there are multiple David Spraggs in this world. So if I just said, if the person's name is David Spragg, what do you get? Well, you get essentially what the no-fly list in the US and a bunch of other things, right? There are mistakes you're going to make just using a name. It's not a unique identifier. And so let's use just the pointer itself. So is the pointer the same as what's already in there? If so, don't do anything. Get the heck out. Otherwise, add the person. All right, we're going to add the person to our group. So here we go, APS group. Where's the next available position in this group? Well, if let's take a number here. If this value was 4, what's the next free space? It's at position 4. 0, 1, 2, 3. Position 4 is the 5th position. Okay, that's my wife here. Okay. I don't think she realizes I'm actually recording a video. Okay. Anyways, hopefully there was nothing incriminating in there. So S group size. That is actually, if I have 4 people in there, position 4 is the first free space. It's weird, but the math will eventually come to you and it'll make a lot more sense. So at this position, I am going to equals, and then we're going to have another problem with this, by the way. Okay. And then S group size plus plus. So S group size is going to increase by 1. Maybe I'll let you guys give a chat message or something like this for this one. What's wrong with this? There is something wrong with just doing this. There is a particular case where things are going to go really badly for us. Where do things go really badly? I'll wait. No one made a comment yet. You can also chat, but most people seem to like using the chat window instead of actually talking. What will go wrong with this? Or is everyone asleep and they're not even listening? That's why I'm taking a little break here. Nada. Oh, there we go. Thank you. At least somebody's awake. All right. Okay. Behind as in not understanding, or behind as in there's a lag? Okay. Okay, can I back things up for you guys? That's why I wanted to make sure we did this. IDK, I don't know. Okay, hopefully. I'm not used to the you kids and your slang. Is there anything I can back up for you guys when it comes to what we're talking about? So to reiterate what we're doing, last week, and you've had this code available to you, we made a human class. The human class has parents. It has a name. Each instance of type human has 2 parents, biological parents, not the people that raise you, but the people that provided genetic material for you, 2 parents, and we're making a gross generalization that, mother and father from a genetic standpoint only, not anything about any life decisions one makes. Okay, so 2 biological parents, except if you're Adam and Eve. We're also making, just because I wanted something where it stops hard. We don't have that any other case. So besides having biological parents, each human has 2 biological parents, and every single person has a name. We have a particular class, and we can get the info for this person calling this function. We can set the father calling this function. We can get the father calling get father instead. That's a getter method. We can set the name, we can set the mother, we can set the father, we can set values. The idea is, as human class, every instance of type human, an object of type human, like me, like you, we're each objects of type human. Every single human has a name and a biological mother and a biological father, sort of by definition, unless you were cloned, in which case I apologize for being insensitive if you were cloned. Okay. Or mitosis, perhaps. Anyways, so you presumably have a biological mother, a biological father, and you have a name. Those are assumptions I'm making. And the class itself keeps those variables around. What we're doing now is I want to do something completely weird just because I wanted to make another class for you guys. I'm going to make a study group class. The study group class just has an array. It doesn't have to be an array. It has a collection of humans, right? Like a study group. and we don't want to have any duplications of any of those humans in the study group. So I cannot join the group, that same group twice. I should be able to add people to the study group, remove people from the study group, get the size of the study group. And I guess my point that I really wanted to make is, how do I implement this? And the answer is, you can almost do whatever you want. That's sort of the point. No matter what you could have done, you could have been storing this with vectors. You could have been using linked lists, which we've already looked at. You could have been using almost any number of things. I'm going to do a little quirky thing. I'm going to make an array to store all these people in the group. I'm going to just keep the pointers to these human objects. So for every single pointer to a human, it's a member of the group. And if, that's the thing I was asking about, if the array is too small, like if I fill up the array, this thing starts off with size 4. If I have tried to add a 5th member to the group, what happens? So I'm adding a member. What if I already have 5 members? What happens? I try and put a member into position 5, which is outside of the array of the bounds of my array. My array has 0, 1, 2, 3, 4. That's it, right? There's 5 elements counting from 0, 0, 1, 2, 3, 4. And the 5th one is outside of my array. I'm out of space. All right, so you can stomp on the memory if it is dynamic as well. That's the problem, right? We do not want to be stomping on other memory. It is one of those. If you do it, you'll get some weird crap happening to your code, and bad stuff happens. That's a great question. So if you go outside of your array bounds and you don't have some kind of test for it, bad things are going to happen. So what I actually want to do, let's do this. Here would be a perfectly fair thing to do. Assert. I may actually want to keep another variable around. Is less than max group size. We're going to keep another variable around called max group size just for such an occurrence. Okay. Okay. And it's giving me an error with this because I haven't defined max group size yet. Unsigned int. Oh, come on. There we go. Max group size. Okay. I'm going to set this when I make my, when I make my class, max group size is equal to this thing here. This thing isn't going to change. That max group size could change. Okay. So I want to say, hey, I'm guaranteeing that the size of my group is less than the maximum group size, because what I'm going to do next is I'm going to add something at the next position. If I happen to have, if I'm already filled up my group, I would like that to explode on me. I want to say, whoa, 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 something bad happened. We're going to actually fix this properly, but we're going to put an if statement in here in a second, but that is the kind of sanity check that you can do with an assert. If bad stuff's going to happen, like I'm going to start stomping on memory, blow up before I start stomping on memory. It doesn't slow down your code. It doesn't do anything. It'll just test, like, is this a sane value? Okay. If I'm going to go outside of memory, what I really want to do, and this is where it gets fun. If I'm going to go outside of memory, what I need to do is just, let's say, double the size of my memory, and now I have more spaces to fill. And if those get filled, I double the space of my memory again and fill up those next spaces. So I'm going to, if out of space, double the array size. I'm going to double my array size and then copy everything over. Okay. So that's going to be a little weird. So let's go through it nice and slow. Okay. So what I need first is if my S group size is greater than or equal to, so I'm going to just copy this thing here. If the size of my array that I'm putting things into, or the size of the group right now is larger or equal to the maximum possible group size, well, then what I need to do is I need to transfer. What I'm going to do is I'm going to make twice the size of an array, transfer everything over to that new array, delete the old one, and then I'm good to go again. It's pain. But the point is, no one knows that you did this. They just think they can add elements to this group, and no one's the wiser. So let's see here. I'm going to make a brand new array. So instead of this, I'm going to call, actually, let's just call it human. New group. Just give it a name like that. It's equal to new human pointer. And we're going to make it twice the maximum group size. Actually, let's just maximum group size is equal to maximum group size multiplied by 2. So I'm going to double that. I'm going to just make it to the new maximum group size. So it's twice as big as it was. This new array is twice as big as the old one was. I'm going to copy everything over. Is less than let's see here. I don't want to use max group size. I'm just going to use the S group size. Okay, I plus plus. And then I'm going to AP new group at position I is equal to AP. I want to see what the name of this parameter S group at position I. Just copy everything over. Okay. Then what I need to do is let's give it another. It's a pointer to pointers. Old group. I just want to keep what my old group was called, AP. It's just pointer to pointer. So I'm now pointing to this new array I've made. I just updated point to the new array and delete the old one. And then at this time, what I need to do is call delete on. Okay, so I delete the old array, make a brand new array, it's twice the size, copy everything over, delete the old array, make the new array the array that I'm dealing with. Okay, when I'm done this, what should I be able to say? Well, I sure as heck should be able to say that the maximum group size is larger than the size of my current group. And if it's not, well, there is a problem here. If the max group size and the size of my group, if I made this constant thing that I was using right here, if this was 1, that would be a problem. Right? But that's something I can deal with, or at least can consider. And my assert will actually find that particular issue. Okay. I'm going to put my new member in the group and increment the number of members of my group. Let's do this. I is less than S group size I plus plus. And I'm going to, for each of these things, so AP S group at position I. Can I print get text info? Okay, this will return a string, right? And okay, so I can do cout something like this. And unless I want to use standard namespace, this will just solve my problem. All right. So for each, actually, that's not going to work. That's not working. That's not the problem. Let's find out. Add IO stream. That'll do. So all I've done is printed off all the members of my group. That's all that does. I want to remove a member. So I'm going to use the same for loop. It's going to go through each of these things. Okay, and instead of this cout statement, I'm going to say if p to remove is equal to, oh boy. We'll see this in a second. If this is equal to APS group at position I. So if the thing I'm looking for is this particular element here, what I want to do is I actually want let's think about how I could do this. So I have an array full of elements. I want to get rid of the one in the middle. I could set that to null, but then I get a bunch of null spaces in there, and counting how many elements, how many members I have in my group becomes a pain. And now I have all this extra space. Let's say I add 20,000 people, and then I remove 20,000 people, and then I add another 20,000 people. Well, I'm going to need 40,000 places for 20,000 people. So there are ways around this. One of the simplest ways is, well, how would you do it? You could make a loop that shifts everything over. That's perfectly fair. That's a reasonable approach. Other approach, well, why don't I just swap the very last element into this position? With the one caveat, let's see here. The one issue would be if I only have one person here and I try to remove it, will that cause problems? That would be my issue there. Okay. Still worth looking at. So let's do that. APS group at position I is equal to APS group at position S group size -1, the last position. And so we're just removing that particular group member. Okay. And the issue is going to be if my group size is equal to 1, then I'm fine. I wouldn't do anything at all, really. I replace it with itself. Okay. If the group size is 0, position is equal to -1. So I just want to make sure if if this is greater than 0, then I can do that. And my curly brace is in the wrong position. All right. So I shifted, all I did was take the last element, just stuffed it in wherever I was removing this element. Okay. I decrease the size of the group. And and then I want to just get out. I'm done. There's no more searching around for anything. I got rid of the last element. Okay. And for group size, what I need, and I'm just going to copy this line here. Oh, actually, I don't even need that. Return S group size. We have it around. Okay, let's save that. Let's compile this. Let's see what happens. I probably have nothing to even test my code yet, so let's. Oh, it succeeded. Well, that's impressive. I'm not expecting much, but let's find out how it happens. So let's go back to main human. I had this weird for loop where I'm setting up humans with the 2 people in front of them. So imagine a line of people, 40 people long, and all you're doing is the 2 people in front of you are your mother and father, and you go, okay, but it's stupid, fully admit. But Just, I needed something with parents, just for fun. Okay, let's add a couple. Let's make one of these study groups. Group. And we can either, it doesn't take anything else? No, right? So it's just going to be left alone. So I should, oh, I need to include the study group. And you're right, I got to check my chat here. Okay. I just have something. Yeah, there you go. So I have a study group, and then I'm going to dot add member, and it's going to be a humans at position 0. Wow, that's annoying. Position 0. Let's add a couple more people in here. 1, 2, 3. Let's put 4, and let's try and add 0 again. Let's try and add 0 again. And then what I'm going to do is I'm going to say group dot print members, and then a group dot remove member and a humans at position 3. Let's do that. All right, and let's remove another person. Just that would be a pretty good test of things. And let's remove this person. All right. Let's see if it works. And I'm going to check your chat. Thanks, guys. Okay. Okay. Can I increase my array size exactly the size of the new member we are adding each time? I wouldn't. That's a great question, Sarah. So you could just increase it by 1 to add the 1 extra element. The question is, if I have to do that big transfer of all of those people each and every time you increase by 1, and then you add 1 more, they don't add 1 more. Let's say you really underestimate and you say, I have 100 people. Let's take my BIT2400 class. I thought I had 10 students at the beginning of term. If I had to do a massive overhaul of everything when I got an 11th student and then a 12th student and then a 13th student, I'd be in real trouble because I got up to like 27 students at some point. And that's still small compared to you guys. But every single time a new one came in, I had to do a whole lot of work. What I want to do is, I don't want to do that big operation of transferring things over any more than I have to. So traditionally or frequently, we'll just double the array size. It's a whole lot cheaper than trying to do that transfer, but that's a great question. That's equal to the member we wanted to add into. Add a space, or you cannot add to your array in C. That's, or C++ either, or Java for that matter. It doesn't dynamically change the size. It is solid and it's stuck in a particular size. So I can't just say, I want it a bit bigger. You don't know how much memory you need. So you have some starting size, but this, what we did here, no matter what, no matter how many people you add to this thing, it will enlarge appropriately to deal with the proper size. So if I add 50 people, it'll still keep on doubling, moving everything over, and then it'll handle, let's say 50 or 500 humans that we've added to our study group. It'll just keep on automatically doubling for us. So what I could have done is done a for loop, adding each member of this array here, right, of each member, all these 40 people, and just seen what happened. And it would double in size, until it was able to accommodate all 40 people. Nice. All right. So did that work? It worked. I have no idea what's going to happen here, so your guess is as good as mine. All right. So we're going to make a new group. This is automatically going to give us our constructor. In fact, let's put a breakpoint right in our constructor, just in case you didn't believe me when this thing gets called. Boom, right here. Let's see what our chat message is. Nice. So first thing right off the bat, we're going to call our constructor whenever we make one of these things. So here's main human, here's me. I'm going to call my constructor. I don't even need the word new. It's automatically going to get a constructor. Okay, after that point in time, I'm going to add a whole bunch of people. Let's actually add a couple more. Why? Because I want to see 5, 6, 7. Okay, I want to be bigger than what I need. Let's do one more. 8. And this is going to make it, it's going to go from 4 to 8. I'm going to need one more. This is 9 different elements here. 0 to 8, 9 elements. So this will require me to do that doubling up twice. Okay, I'm also going to try and add zeros twice. I'm going to remove the 8 here just because I want to see that in action. And I'm going to remove the 0 at the front. And then I'm going to print the whole thing out. Let's build one more time. Okay, moment of truth. Let's find out what happens. I always expect my code to break. You shouldn't, people keep on saying, oh, it's so hard, my code breaks. Yeah, I expect it. That's sort of your perspective on things changes once you've done this enough. All right, I called my constructor as soon as I started. If you want to see the call stack, see this thing right here, this is call stack. I went down here, I can see where it's getting called. Where's the call? Where is this call stack? There it is, right here. That's where I am. I'm inside that function. All right, I'm going to make my array. So I made a brand new array of size 4. My size is 4. My maximum size of my array is going to be equal to 4 in a second. 4. All right. Okay. Next up, I'm going to let's just run it and see what happens. It might blow up. I don't know. Let's find out. All right. This is all my destructor, so I got to go back up here. Here we go. Okay. Here's me creating all these things. Here is me printing off. So this is, let me see here, right here. This thing here are all the different members in my group at the start, after I did all those adds. So I added some elements. I added some more, I added a whole bunch of people. I added, notice I even Bob 6 is right here. And I'm wondering why that's the case, unless I call delete afterwards. So Bob 0, Bob 1, Bob 2, 3, 4, 5, 6, 7, 8. Oh, Bob 6. Oh, that's, so let me make a slight change to make it a bit more obvious. And by the way, if you don't believe me with this whole transferring everything over, let's plop a breakpoint in there. We've already broke point about that. Okay, so I want to go back to my main human. I added a bunch of members. I print. I want to do a cout statement. Hopefully that's going to work. And L, right. I'm going to make a blank line essentially. Let's do this. End of something to follow would make it a bit easier to follow. And of removing members. Okay. In case you didn't believe me, one breakpoint should be here whenever it stops. I should have stopped. Unless I have an infinite loop here. Hold on a second. What the heck happened? I have an infinite loop here somewhere. It looks like it at least. Study group. Did I break point here? No. Let's pause it. Let's stop it. What's going on here? Let me debug this thing. So I have, what did I do in the past from the previous one to this one? Okay, still have an infinite loop here somewhere. Okay, so let's drop in my study group. Let's go up to here. This is where I know I hit this, and I'm going to walk through my function to see what happens. If my thing can go out of the way. There you go. So I should hit a breakpoint here. I want to look at this thing here now. How is it that this is not actually going in? All right. Happens to the best of us. Okay, here we go. Got there. Fine. I probably just did something really stupid. It's in my StayHuman function. All I did was one step forward. Why is that not working? All right, let's one more time. I'm going to walk into my function, F11. All right, let's see what happens here. Set the that should not happen. This is perfectly safe. As far as I can tell, it's perfectly safe code. So why is this? Okay, let's see it one more time. I'm going to walk into this function. Okay, the name is equal to blank. That's fine. That should not have done anything at all. Oh my. C code, what did you do to me? I can't even pause. I can't break. We're having a problem in this cout statement, according to this, despite the fact that a cout statement should not ever cause problems like that. So let's have a, this is shocking. It really is. Okay, let's. What the hell could be causing this? I probably did something really stupid in here, but test human. Okay. Main. Okay. My foo function shouldn't do anything. That's fine. The foo function just gets a name, does nothing. And we didn't even get into that thing. We got to this line. I go into the function. The my name is equal to test human, creating an inline. The cout statement should be working fine. And yet I'm getting this. Wait a second. Hold on. Some of these things just unfortunately happen. Okay, I'm going to include the IO stream from here. That once, just in case I have multiple instances of the same main human, but this is something I wouldn't expect you guys to figure out on your own. Include that. IO stream search.h. Let's put that also in. Study group needs to know about studygroup.h. Needs to know about human.h. Human.h is going to include these asserts. got to be kidding me. Okay, I may have to bail on you guys on this one because there's something really weird going on. And I have no idea what the heck this could be. I did nothing to the code. This code has not been changed or touched at all. Unless I know what it might be. Where increments causes it? Potentially, but I didn't go through that code yet. However, there is something that did get called. How about namespace standard? That's a possibility. We can have a look at it, but namespace standard should be in here already, or it's in human.h using namespace standard. So everything in the entire project should be using namespace standard. I can get rid of it actually from here. So that actually might be part of the problem. That's a great suggestion, by the way. Notice this pragma once thing. It's essentially, I have one of the ways you can make sure you're keeping your code nice and clean is you can put everything into the one .h file that everybody needs to have. In this case, human.h, everybody needs to include human.h. So since everybody needs to include human.h, well, I can put all of my includes in there. I think, though, what I have a sneaky feeling is I know this gets called right away. Without doing anything, it gets called right away. Is there a possibility of this causing a problem? That's part of that's what I'm contemplating, at least, right? It's a study group. I have a max size. This thing is making a brand new, but I should only get there when I call the constructor. Okay, let's see one more time. All right. Now, that would be too easy if it actually fixed the problem. Why would that be? It almost looks like it's it looks like it's waiting for input. Why the hell is it waiting for input? Okay, let's just continue. That was the problem. It looks like it's running a cin, but there's no cin statement. So why is it looking for a cin statement? I don't know. I'm all sorts of confused. Okay, we're calling our constructor. We know that the constructor is going to go in here. Okay, we figure out that size. So the size of my array is 4. We're doing this part. All right. I have no idea what the heck that bug was. All right. We're going to add a bunch of humans. As I go through, I'm going to hit, on the next one, I should hit, okay, one more. This should cause me to double up my array. There I go. So if the size 4 is greater than or equal to the maximum possible size, I'm going to double everything. So my maximum size of my group is now 8. The new array I'm going to make is going to be size 8. I'm going to then 1, 2, 3, 4, stop. And then I just update what my old and my new array are, delete the old array. And now I have this nice array with 8 spaces available for me. I transferred everything over to a new thing and got rid of the old. Okay. I have no idea what the heck that cin thing seems to be. Okay. Is the group size less than the maximum size? It should be. It's 8 versus 4. That's fine. I'm going to put it in position 4. In position 4, I'm going to put this new value, and then the size of the number of elements I have is 5. I should get it one more time. Oh, I thought it would have been further along than that. I'm going to just get rid of these breakpoints, but we've hit it twice. We know we've hit it twice. And now let's have a look at what this thing outputs. Honest to God, I'm so confused about what happened with that thing. Okay. Bob 0, 1, 2, 3, 4, 5, 6, 7, 8. That's me adding those 8 things. I even tried to add Bob 0 2 other times. They were ignored. Then I'm deleting Bob a bunch of times. So let's see what I have a question. When you made an array bigger, why did you make the pointer point to the old array, then old array is equal to new array, and then delete it. Okay. I made a Brent. That's a great question. Let's have a look at this code again. So I had something called old array. It's just a brand new, it's a pointer. It points to the old array. Because what's going to happen is when I set this, what was my array to this new array, what happens to my old array? So I'm pointing to this over here. Then I say, no, I'm pointing to this over here. There we go. What I was pointing to something over here. Nothing's pointing to it anymore. So what happens to it? I have no access to it. The thing I was pointing to, nothing's pointing to it anymore. It doesn't automatically get cleaned up like it does in some other languages. I need to explicitly clean it up. That's why I needed to keep a pointer to what was my array so I can call delete on it. Otherwise, I won't know that exists anymore. And if I try and delete it, I could have called, yeah, I could have done that actually. So let's try that. Instead of this, because you are right, I could have deleted. I can't believe I didn't think of that possibility. Much easier, right? Delete the old array. I already made the new array point to the new array. That would also work. Nice. Yep, but I still need to delete, Katie. So that's a great question though. Okay. So I have no idea what was going on with this thing, but let's have a look at what I had here. I have removed, let's look at what my function actually removes. It's going to remove element 3, element 8, element 0. Element 3 is, I'm assuming it's this Bob 3, right? I'm going to replace this 8 with the 3. So the 8 is going to go into position for 3. Position 8 is the next one. I should just, and then position 8, we'll find this 8, remove it from this position here. Okay. And so then the 7 would move down into position 3. And then positions, I may have a bug in here. That's good to know. So let's have a look. 6, 1, 2, 7, 4, 5, 6, 8, 3, and 1 and 0 are all missing. That's the right thing. Oh, there you go. So I removed element 3, pull up the 7 in there in its place. And then when I removed element 0, it's from down here, which was element 6, and I plopped it in there. So essentially all I'm doing is take the last element, stuff it where the old value was. I could have shifted everything down. That would have also been a perfectly acceptable solution. It's just trying to find easy ways of dealing with an array. The point is not whether we can do arrays. The point is, do you know how I implemented that? Like we just went over it, but if I gave you this the study group thing, let's say I also just hid the member variables because you really shouldn't be seeing this. If I just showed you this, what would you conclude? You would say it's a study group that I can make. I can add members. I could print out all the members. I can remove a member. I can get the size of the group. You don't know if it's using a vector. You don't know if it's using a linked list. You don't know what it's using. That's the point. Because you do not know what it's using, I could hot swap this and plop in a linked list and no one's the wiser. That's why we're doing this. The idea is you shouldn't know how the other person implemented things. If they did if they coded it right, they're blissfully unaware. Okay. I wanted to do one more thing before we get going. So let's have a try at this. This is why I needed this main human thing. I wanted to do this print out all people, my family tree. So here's how we're going to do the print out my family tree. And let's save it. All right. We had this thing I said we're going to deal with it later. This is what we talked about the very, very beginning. I said, I'm going to have to come back to this later. I may need to play with it a bit more as well. The idea of this is going to be, I'm going to make a really big long string. All I'm going to do is keep on getting the name of myself and then the name of all my ancestors. So I'd have my name, and then I'd get the name of my parents, and each of their parents, and each of their parents, and each of their parents. Maybe I just want everybody that was ever in my family tree. So I'm not going to worry about the order of things. Or I could say how many people are in this family tree. That would also work. That would be, let's actually do that. It might be easier to deal with. Okay. Int, that's an unsigned int. Because I know it's only positive. I'm not going to have negative number of members in my family tree. I'm not that bad. Okay. Family tree size. Okay. So given me, figure out how many people are in my family tree above me and myself. That's what we're going to do here. And here's human. All right. So the idea here is I'm going to just return, let's say 0 for, let's return 1 for now, myself. What I want to do is I want to figure out how many people are on my mom's side of the family, how many people are on my dad's side of the family. This sounds like the same question though, doesn't it? I figured out how many are if I can figure out how many are on my side of the family, let's pretend, for instance, that I can figure out how many people are on my mom's side of her family. Let's say it's 10. Let's say my dad's side of the family has 20 people. So 10 and 20, let's say. How many are in total on my side? For me, in my family tree, is 10 plus 20 plus myself, right? Everyone on my mom's side, everyone on my dad's side, and me. So why don't I ask my mom, another object, hey, how many people are on your side of the family? You can do that. Say, hey, mom, how many people are on your side of the family? And I go, hey, dad, how many people are on your side of the family? And then I just add myself. This is recursion. This is weird, wild stuff. So let's have a look at this. What I want is I want to see if I need to see if I have there's a possibility if I'm Adam or Eve that I don't have a parent. So if this, we talked about the this pointer, this I always forget the name of my function. So I write this in the arrow and it tells me what functions I have available. I'm lazy. If get mother returns a pointer to a human. So does not equal null if you want to be very, very, very explicit. So I need total size, let's say. All right. So total size 1 for me. I want to then say, well, why don't I get my mother? This will give me back a human. And then call get family tree size on my mother. I can do that. It returns a number. And then I'm going to say total size. Hopefully you've seen that before. Total size is equal to total size plus the size of my mom's family tree. 1 plus the size of my mom's family tree. Then I say if this get father, because I don't remember the function names. All right. What? A function can call the same function somewhere else. It's perfectly allowed. In fact, there are entire languages that only allow that. They don't have loops at all. They have recursion. The function calls itself. So functions can call the functions, which can call functions, which can call functions. There's no upper limit to this thing, provided that this thing has, notice we do have a problem, a potential problem. If you do not guarantee that you don't have, if you have a cycle, so your mother's father is you, let's say, some time paradox, right? You have an infinite loop. because it'll go to your mother, which is then go to your father, which is you, which then goes to your mother, which goes to your father, which is you, and then back and forth, just like a time paradox. So if we have something where we don't force it to get to some stopping condition, we have an infinite loop, but we will just keep on going. In fact, we'll actually crash. It'll cause a stack overflow, not just a website. It causes stack overflow because it's the call stack overflowing. The number of calls to functions to functions to functions to functions eventually overflows. This thing goes from myself to each of my parents, calls their function to get the family tree size. And each of those things then go off and call their parents to get the family tree size. So let's see if I can get this, or let's see. I'm going to just move it to the main function here. And then I have this weird set of humans, right? So let's do that A humans at position 39, right? So, and this would be get family tree size. I don't know how big this thing is going to be. So we're going to walk into this particular function. Unsigned int tree size is equal to this. I don't know how big this thing is. I honestly have no idea. And we're also going to see how badly this CN out crap that we went through last time works. I have no idea what the problem was last time. All right. All right, let's run it. Oh, and now it went fine. Gremlins, honest to God, and everybody goes through this. It just relax and just take a deep breath sometimes and work through it. That's why you also can't work until at the last second for your assignments. Okay, I'm going to walk into this function. I'm going to go into the human 39's family tree, and we're going to see what they have. So, does human 39 have a mother? Should. And I'm going to get the size of the mother's family tree. Oh, do I have an infinite loop? I might. If I have an infinite loop, that's pretty awesome. Not actually awesome, but it says something about mistakes one makes. Okay, so if I get the mother and I call get family tree size, it will get me this size plus, okay. I wondered, oh, I have one of those infinite loops. I'm just taking the next two people in front of me. But the person in front of me, their mother is the father, which then causes it to, yeah, I think we have an infinite loop here, or at least it goes off into a weird recursion. All right, let's have a look. This thing is what's wrong. I'm setting up my parents, my mother, my father, being the person in front of me and the person in front of that person. The person that's right in front of me, that's the child of the mother, so therefore the mother, and the mother becomes a father. Yeah, just it's bad. We have almost a Fibonacci type sequence here. So let's do. How would I want to do this? I'm going to make it everyone's going to have the same mother and father. That will fix it temporarily. So the depth of everyone's tree is going to be 1. Is going to be 3 elements: a mother, a father, and itself. Okay, or I can manually set these up if I wanted to. So let's at least have it see what this does. Okay, the total is equal to 1. I have a mother. I then get the parent of the mother of my family tree, which should be element 0, I guess, and the size of that. That should be equal to 1. So therefore 1 plus 1, 2. I also have a father. I'm going to add 1 to what I'm figuring out here. So it should be 3. The total size should be equal to 3. But if I had a parent which had a parent which had a parent, then I'd be all set. Let's continue. That's my study group thing. All right. So let's do one little change because we're out of time actually, but let's just finish it off as much as I can. Instead of that for loop, let's see if I can change some stuff around. I'm going to get rid of this for loop. Okay. I thought it was silly. I didn't realize just how dumb this was. Okay. So person number 2 to this. 3 3. 3 3. It's going to look a little gross because I think we're going to make person 5 be the child of two, like a brother and a sister or something like that. But that's, you know, gross, but still, we're going to do it anyways. Okay, and we're going to add this. So get the family tree for humans, add person 5. That should do it. And I'm going to, I have this in here. That's extra. So what should I have? Each of those people have 2 parents. So I should have a grand total of the mother's side of the family has 3, the father's side of the family has 3, and then the child should have a grand total of 7. 3 plus 3, 6 plus itself. Okay, and let's throw this in, and let's just do one step and make sure we get 7. And the value, 7. There you go. But this is what we're asking for with the bonus question, that how would you actually parse through a tree? Because you can call a function, can call itself, return a value, and then you can deal with whatever that recursive call did, whatever that call, the function call to another node, and figure things out from there. It gets a little wonky. Some people naturally get this. Some people have a real hard time. We're not officially teaching it in this class. I just wanted a bit of an extra challenge, fun question for you guys. All right, let's see if you guys have any questions. Otherwise, I'm going to let you go. I'm hoping this clarified things. A lot of objects is just practice. Again, I'm a broken record here, but it's a lot of it is just trying to make a bunch of objects, making sure they work, trying to use inheritance, making sure it works, trying to use polymorphism, which we'll get to, seeing if it works. We happen to hide information hiding. We hid how our groups were being formed. We made an array that automatically adjusts its size based on the number of people that are in the group, and no one's the wiser. I don't have it hit an upper limit, so it could be a linked list or it could be a dynamically adjusted array. That's why we do it certain ways. And you'll see that if I have an array that has to double its size and transfer everything over, sometimes a linked list is a better approach in that case, because I don't have to make a brand new array, delete the old one, transfer everything over. And so you'll get all these cost benefits for all these approaches. Okay, somebody fake is calling me on Hangouts. Okay, if nobody has additional questions, I'm going to let you guys go. I'm hoping that was helpful in some way, shape, or form. All 8 of you. Oh, wow, that's sad. So I'm hoping it was useful. All right, thanks everyone, and I will talk to you soon. All right.